Okay, so here's a little review video for the geometry, transformations, and congruent triangles. So start out with the transformations. So the rules again for rotation, if we're going 90 degrees, is that every point xy is going to become negative y x. So we're just going to take the original coordinates and apply that transformation to them. So for example, the point h originally is at 1, 2, 3 is at 3, 3. So if we apply the rule, the x is now the opposite of the original y, so negative 3. And then the new y is the original x value. Okay, so that point should be negative 3, 3. So negative 3, 3. Let's miss that by 1. Negative 3, 3. So that's going to be h prime. And follow the same rule for the other points. J originally was at 4, 3. So when it transforms, again, the new x value will be the opposite of the y, so negative 3. And the new y value will be the original x value, so negative 3, 4. Okay, will be j prime. And then the last point, I. The original coordinates on I are 3, 5. So applying the transformation rule, again, that's an x and a y, so then the new coordinates are going to be the opposite of the y and the original x. So negative 5, 3 would be there. That's going to be I prime. And then we can fill in the rest of the figure. And it should end up looking like that. That's the image. Okay. For translations, these are just shifting or moving the points, so just one at a time. If we go 3 units to the left and 5 up, so starting with A, if I go 1, 2, 3 left and up 1, 2, 3, 4, 5, so A prime is going to be there. B prime, 1, 2, 3, and up 5. C prime, 1, 2, 3, and up 5. And D prime, 1, 2, 3, and up 5. Okay, so translation is just a shift, keeping the same shape, same size. We are just basically sliding the points. All right, then we're moving on. They give you a transformation. We need to figure out the rule. So on this one here, I'm looking at where point y ends up over here at y prime, and I can see w and x actually stayed where they were, so that's making me think it's some sort of reflection over this line right here, because y is the same distance away from each. So this would end up being a reflection, and that line is just x equals negative 1. Okay, that's the equation of the line, so this is a reflection over that line. All right, number 4, this one is just a shift. Each point is moving 1, 2, 3, 4 units to the right. R goes 1, 2, 3, 4. S goes 1, 2, 3, 4. And P also went 1, 2, 3, 4. So this is just a translation. Four units to the right. Okay, which we could also write. Sorry, it's not sloppy. We could write as xy maps to, we're adding 4 to the x value and keeping the y value the same. All right, moving on, number 5. So what additional information would be needed to prove the triangle's congruent if we were using angle, side, angle? Okay, so with these, the idea is we need to notice that the side is the included side in between the two angles. So based on the markings on the diagram, we already have an angle up in angle A, then we have a side right here, so the next angle would have to be that angle. And in the other triangle, if we look, we have angle Y given, then a side, so the next angle to make XY be the included side would need to be angle X. So we would also need to know the other additional information, were the ones that I just marked. It would be that angle B must be congruent to angle X. Okay, number 6, if we wanted to use hypotenuse legs, so that means if you have right triangles, all you need to show are that the hypotenuses are congruent and one of the legs. So in this case, the marked information is a leg, okay, because the hypotenuse on each are the ones across from the right angle, So since we don't know those are congruent yet, though, that would be the thing we would need to know. So we would need to know that RS is congruent to CD, okay? And then we already had a leg marked, and since the angles were given to be 90, that's how we knew it was, they were both right triangles, and that's why hypotenuse leg actually works. Okay, moving along. Some of the other problems. Number 7 here. Can we determine if these triangles are congruent? If so, state how we know. Okay, so with number 7, everything that's marked, we have an angle, we have a side. We can also then use the fact that we have vertical angles here and here, and I think that's the only other thing that we would know. So based on that, it appears that we do have angle, side, I'm sorry, I said those backwards, angle, angle, side. And then the other triangle, angle, another angle, and a side. Okay, so angle, angle, side would be able to be used to prove those are congruent. Okay, and the next one, let's see what we have. On the first triangle, we have a side, then an angle, then a side. But on the second triangle, it's actually an angle, then a side, then a side. Okay, remember that one's the old donkey theorem, angle, side, side, right? Doesn't work. So we don't have side, angle, side on both. So this one would be a no. We don't know they're congruent because we don't have side, angle, side, or any of the other options. Okay, and the 4 options again, just as a review, it could have been side, 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 angle, side, angle, side, angle. I'm sorry, angle, angle, side, angle, or the new one with the right triangles, hypotenuse leg. Okay, we didn't have any of those. Already, complete each congruent statement. So they're basically telling us these 2 triangles are congruent to each other up here. So we should be able to figure out which spots are corresponding. So for FG, I'm just looking at where that matches up, and the way it's ordered, that was the first 2 letters. So that needs to match up with segment LJ. Okay, those are corresponding parts of congruent triangles, so they are congruent. And then in number 10, same kind of thing. If these triangles are given to be congruent, it's just a matter of lining up. Angle T would have to match up its corresponding angle V, but we need to be careful because angle V is kind of ambiguous. You know, it's which one of those 3 is angle V. So we might need to look a little deeper here. So TUV is this. That needs to match up. Actually, let's go back. TUV, right? Triangle TUV. So angle T, though, in that triangle is actually UTV. Okay, if I want to talk about angle T. So UTV would actually match up. If you look at the order, it's U, then T, then V. We need to match up with angle Y, VX. Okay, I'm just looking at the order it's written in. UTV, so the middle, then the left, then the right. So it would be the middle, then the left, then the right. So YVX for that one. All right, then using isosceles and equilateral triangles. So in this picture, if we know we were given 2 congruent side lengths, that means the legs, the angles across from them are congruent. So that angle and that angle must match. So that means right here we have ourselves a 70-degree angle. Okay, and then angle X is leftover. We know that all triangle sum is 180 for the angles, so we have 70 and a 70. So we have 140 plus X must equal 180. So X must be 40 degrees. Okay, number 12, if all 3 sides are congruent, there was a little corollary that said all 3 angles are congruent. And in a triangle, since the angle sum is 180, if all 3 are the same, they each must be 60 degrees. Okay, so that's an equilateral and thus equiangular triangle. Okay, then finally moving on to the proofs. So let's see what we got here. We're trying to prove, I'm going to take a peek at what our goal is here. I want to show that AB is congruent to CD. So I'm just going to mark, I want to show that AB is congruent to CD. I'm not going to put the tick marks yet because I want to prove them. But let's see if we can get that together. So we're going to start out with the given. I'm not going to rewrite it just to save some time here. Okay, but AC and BD bisect each other, so they're kind of meeting at point M. You could think of point M as the midpoint of both of them. So then what does that mean? If segments are bisecting each other, it means you're creating congruent segments. Okay, AM would be congruent to MC, and then DM would also be congruent to MB. Okay, so that would be a good next statement to use. AM is congruent to MC, and DM is congruent to MB. And the reason on that, since we just had a bisector, this is by definition of bisector. Okay, we create congruent segments. Okay, I'm doing them both on the same step just because it's the same reason. Alright, so what else can we do? So it looks like in the two triangles we have side, side. If we could somehow get their included angles to be congruent, I think we could have congruent triangles. So how would that angle be congruent to that angle? They are vertical angles, right? So we could say angle AMB is congruent to angle DMC. And again, vertical angles are congruent. Okay. And now I think we have enough to state that we have two congruent triangles. So let's go with triangle AMB. Okay, and let's order this one in the correct way. If I'm saying AM first, that needs to match up with CM. Okay, because of the corresponding part, right? Because we had this statement, AM is congruent to MC. And the reason on that, again, is going to be, we have side, angle, side congruence. And now that the triangles are congruent, we know all of their corresponding parts are congruent. So therefore, let's make sure this matches up. AB, the thing we're trying to prove, AB, right? AB matches up with CD. Yep, so those are corresponding segments. So AB must be congruent to CD. And that's the one corresponding parts of congruent triangles must be congruent. Alright, and the last proof, let's see what we got here. We are given some angle bisectors, so let's think about what we got there. So if EF bisects angle GEH, so EF right here bisects angle GEH, so the left side, what that's telling me is it's creating two equal angles. Okay, and we'll get this written up in a second. And then similarly, EF also bisects GFH, so that tells me those two angles are the same as well. And I'm going to start peeking ahead here. I'm trying to prove triangles are congruent. So we already have two angles in the triangle, so if we could get the included side, we would have an angle, side angle. And it looks like the included side EF is going to be in both triangles, so we can use a little reflexive property and have side, angle, side. I'm sorry, angle, side, angle. Okay, so let's just start getting it all organized here. So step one is going to be all the givens again. And again, make sure you write them. I'm just saving space by not writing them, saving time. And then what that means for us, okay, is that since we have angles being bisected, we have congruent angles being formed. So we could say angle GEF is going to be congruent to angle HEF. Okay, and also on the right side, angle GFE must be congruent to angle HFE. And since they're both the same reason, I'm going to do them in the same step. And the reason for that is the definition of angle bisector. Okay, bisectors always cut things in half. We saw in the previous problem where we had segment bisectors, and this one has angle bisectors. So again, I'm looking ahead. I want to prove triangles are congruent. We've shown two angles in each. Let's now state that we have a congruent side. The included side, EF, is in both triangles. Something is obviously congruent to itself, and our reason on that is the reflexive property. Okay, and now looking at our pictures here, it looks like we have angle, side, angle, so we should have two congruent triangles. And let's see what we got for step 4, triangle EGF. It's congruent to triangle EHF. Okay, I'm just looking back up here to see what we needed based on the angle, side angle congruence criteria. Okay, so we showed an angle, a side, and an angle in both triangles, and therefore the triangles must be congruent.